Hey guys, the objective of this video is to look at the degree of settlement versus dimensionless time, which we're going to be discussing in a second. So, we're going to be giving a graph. So this is a graph which plots the degree of settlement U. So U is the settlement at any time over the final settlement. So it ranges from 0% to 100%. So this is a point of 0 settlement, and this would be a point of 100% settlement down here. And this axis is something called dimensionless time, where we have CV, which we're going to define in a second, T, which is time, and H, which is not the layer thickness, but the drainage path we discussed in the previous video. So, we need to quickly discuss this factor TV. TV is a dimensionless time, so this actually doesn't have any dimensions. The dimensions are all in here, which all will cancel out. Now, the reason it's dimensionless is because with many samples, you could be having a sample which has its final settlement reached in 10 seconds. You could have another example where the final settlement is reached in, I don't know, 20 years. So what they do is they make it dimensionless so that it's dependent on the situation, not on a dimension of time. So that's why it's dimensionless. Now, if we were just define these things, so we have that U equals the settlement at any time over the final settlement. So obviously when the final settlement equals when you're looking at when you're looking at a time of final settlement over the final settlement, you're getting to 100%. So it just ranges from 0 to 100%. And TV equals CV times T on H squared. So CV is called the coefficient of consolidation, and that would be given to you in a question. You don't need to worry about it. It's just a factor, so coefficient of consolidation. T equals the time, and H is the drainage path. So depending whether you have one or two-way drainage. So we're going to do a quick example. Let's say we had a profile of soil. So we have a clay layer, and beneath that a sand layer, and this is where a building would be, and we have the air at the top. So let's say the CV given was 2 meters squared per year, so this is the coefficient of consolidation. And let's say that we had a final settlement of 80 millimeters, which is the same as 0.08 meters. And we want to know the time it takes to get 50% settlement. So how long does it take for the settlement to reach 50%? You would find this final settlement using the process we've done before by finding the change in void ratio, using that formula S equals minus change in EH on 1 plus E. So this stuff you'd use to find that settlement. So now let's pretend we've found that to be 80 millimeters. And just a quick note once again, this H is the layer thickness for the settlement. This H is the drainage path. So they're not these H's are not the same thing. That H is layer thickness and that H is drainage path. So let's go and do this example. So we would use our graph now to find, so we know it's 50%. We know that the settlement is 50%, which is over here on our diagram. So we would go from 50%. You'll see that there's many curves. This might be given in a question. You might just have one curve. You'd usually be told which curve to use. I've just highlighted this one in black. That's the curve I'm going to be using. But yeah, so you just need to know which curve to use. You'll normally be told, or yeah, you'll just have one curve. So I'm going to go across from here to there, and then I'm going to come down here, and I get a value of around 0.3. So that's not 0.3. That's around 0.2, 0.25. Let's call it 0.25. Okay, so I get a value of around 0.25 over there. So I've just found that my TV equals 0.25. We know that TV equals CV times T on H squared. So this equals CV times T on H squared. Let's say that this layer thickness was 6 meters. So because we have air and sand, we have two-way drainage. The excess pore water pressure can escape there and there, which means that our H will equal 3 meters, which is half of 6. And our CV was given to us as 2 meters squared per year. So just be consistent with the units here. We can then find our time would equal 0.25 by h squared, so 3 squared, on top of CV, which is 2. So you can see I'm using meters in years, so that means my final answer will be in years. So if I work this out, 0.25 by 3 squared divided by 2, 0.25 by 3 squared divided by 2. We get 1.125 year. So the time taken to reach 50% settlement, so for 50% of my settlement to occur, I'm at time equals 1.125 years. I hope that helps, guys.